In this paper, we present a successive elimination approach to adaptive robotic sensing. Our main contribution, AdaSearch, is an efficient algorithm for identifying locations of interest in robotic search problems. This video focuses on the application of AdaSearch to radioactive source seeking. The setup is as follows. We represent the environment as a planar grid. There is exactly one high-intensity radioactive point source. However, locating this source is difficult because sensor measurements are corrupted by the background radiation. Sensor measurements are obtained by flying a quadrotor equipped with a radiation sensor above the grid. We take inspiration from the multi-armed bandit formulation and pose this task as a repeated hypothesis testing problem. We maintain confidence intervals for the radioactive emission rate at each point. We can be confident that the highlighted point is the source because its lower confidence bound is greater than the upper confidence bounds of all of the other points. Currently, the state-of-the-art for this type of problem is information maximization, which collects measurements in the most promising locations following a receding horizon. We compare AdaSearch to a version of information maximization tailored to radiation detection. The first trajectory it might take would look something like this. As our belief about the distribution of radiation changes, the algorithm automatically replans to visit regions with high uncertainty. Eventually, the algorithm will converge to find the source with high confidence. Unfortunately, for large search spaces, the real-time computational constraints of this approach necessitate approximations such as limits on planning horizon and trajectory parameterization. These approximations may cause the algorithm to be excessively greedy and spend too much time tracking down false leads. To understand when this is a problem, we implement a simple global planning approach, NaiveSearch. This approach samples the grid uniformly, spending an equal amount of time at each pixel. After the first pass, we might think the grid looks something like this. We repeat this process, moving uniformly over the grid. With each pass, we gain more and more information about the true distribution of radiation across the grid. This process terminates once the source can be identified with high confidence. Our algorithm, AdaSearch, combines this global planning approach with an adaptive sensing rule based on hypothesis testing. In the first pass through the grid, we sample uniformly, just like before. After the first pass, we can eliminate some pixels from consideration. In the next round, we will focus on sampling the highlighted pixels more carefully because their confidence intervals intersect the one with the largest lower confidence bound. Thus, they are still potential source locations. This process continues, and with each round, the set of candidate source locations shrinks until only a single point remains. We implemented all three algorithms and simulated their performance on randomized instantiations of the problem on a 64 by 64 meter grid at 4 meter resolution using realistic quadrotor dynamics and simulated radiation sensor readings. In our experiments, we observed that AdaSearch usually finishes faster than NaiveSearch and information maximization. As we increase the maximum background radiation level, the ratio of AdaSearch's runtime to NaiveSearch's runtime continues to improve. In order to validate our results in the presence of the inevitable mismatch between our simulated dynamics model and the true quadrotor dynamics, we test AdaSearch on a Crazy Fly 2.0 palm-sized quadrotor in a motion capture arena. Notice how the quadrotor flies at nearly a constant speed on the first pass. By the second pass, AdaSearch has eliminated some points from consideration. As AdaSearch proceeds, fewer and fewer points remain. The quadrotor flies quickly through the beginning of the grid, only slowing down over the points that could still be the source. Finally, AdaSearch identifies the source in the corner and lands.